Good morning, students. Today we are going to learn the chapter towards green energy. Now, what is energy? Energy, we know it is the capacity to do work, right? Now, there are certain points related to energy that we already know. Let's brush up through these points. First is energy is basic need for performing different types of work. Types, we have different types of energy: potential energy, kinetic energy, etc. Forms: heat energy, light energy, solar energy, nuclear energy, etc. Now, if I give you an example of heat energy is used to heat our food, to heat our water that we use to take bath. Light energy, we get the sunlight, we use light from bulb, tube lights. Solar energy, the energy we get from sun. And nuclear energy is the energy when we get due to nuclear fission. Now, energy can be converted from one form to another. We know this, right? Now, this fact is used by us to satisfy our needs. Now, in our daily life, where do you think we need energy? Say, take for example, electrical energy. Right from charging our phones to ironing our clothes, then from running our fans, refrigerators, all this requires electrical energy. So now let us study about generation of electrical energy. Okay. Now, electricity or electric energy is produced by electric generators. Electric generators are based on principle of electromagnetic induction. Now, what is electromagnetic induction? It was a principle given by Michael Faraday, right? We have studied this in our physics, right? So, what does the principle state? This principle states a potential difference is generated across conductor whenever magnetic field around the conductor changes. So, we know potential difference is what? Right? Potential difference is generated across the conductor whenever magnetic field around the conductor changes. Now, there can be two scenes where the conductor moves or the conductor is stationary. In that case, we can see how the magnetic field changes. So now we will see the two ways where field around the conductor changes. That is, when conductor is stationary, that is, it is not moving, and magnet is rotating, right? Or the conductor is rotating and the magnet is stationary. Okay. Now, in commercial production of electricity, commercial production of electricity means where large production of electricity is generated. The electric energy is generated on a very large scale. So, large generators are connected to turbine having blades. These blades rotate the magnet at the electric generator and electricity is produced. So, what you have to remember is this flow chart of generation of electricity, the electrical energy. What changes is only this, that is the source of energy, and depending upon what source of energy it is, you will have different types of power plants. Say if it is coal, which is the source of energy to rotate the turbine. So if it is coal, then that will be a thermal power plant. If it is, say your fuel is uranium or plutonium, then this becomes a nuclear power plant. Rest all, the turbine, generator and electrical energy production, all this remains the same. Okay, so this is the basic flow chart for generation of electrical energy. If you memorize this, the only thing changes is this over here. There are little changes over here only. Except for that, everything else remains the same. Okay, so I want you to by heart this flow chart, because this is a very important flow chart which is going to be common for most of your power plant studies. When you study the generation of electricity in the different power plants, this step where the turbine, generator and electricity energy production remains the same. Rest, this all remains the same, and only this part changes. Okay, so let us study the first part of it, that is thermal energy based electric power station. In this, as I told you, always remember thermal energy is heat energy. Remember the thermal energy powered engines in older days, right? We have seen them in movies, right? In those, what we used to use? We used to use coal as fuel. Okay, so let us see this. So fuel here is coal. Now coal is heated, and this burnt coal, what it does is heats water. Now water is heated to such a high temperature that it is converted into gas, steam. This steam, which is under high pressure, is then compressed and pushed. So on the turbine, what happens? The steam turbine, when it is pushed, it moves. The steam moves the turbine. The turbine is then attached, connected to the generator, and this is how electricity is produced. Meanwhile, there is something to note over here. It's written the system for converting steam to water. Here we have boilers for converting water to steam, and then when the steam moves the turbine, the steam again through a connecting pipe goes to the cooler, the cooling system, where the steam is again cooled back. And this cooled steam is given, again forms water, and this water is again converted into heat in steam, and the process continues like this. Okay, so let us talk about the energy conversion here. The energy conversion here, first there is chemical energy in the coal. This chemical energy, when heated, is converted into thermal energy. Then this heat energy turns water into steam, and the steam is moved, that is kinetic energy in the steam. The steam moves the turbines, that is kinetic energy in turbines, and then electricity is produced. Okay, so this is a flowchart showing energy transformation. Both these flowcharts are important for you to understand. Okay, I will give both these flowcharts for you to study. I have also sent a PDF of this textbook so that you find the same over there. So, okay, so it will be easy for studying for you. Another point now is problems related to the thermal power plant. First is, since we are burning coal, it leads to air pollution. Soot particles are generated. Now what is soot? Tell me, what is soot? Soot particles are those particles which are semi-solid and very dark black in color. What happens is these particles, they get mixed with air and then cause respiratory disease. What happens is soot particles are produced due to such burning. Then toxic gases like carbon dioxide, sulfur dioxide, nitrogen oxide are produced. What happens then? Respiratory disease like asthma, bronchitis are caused due to toxic gases and soot particles. Once we inhale these gases, then we have respiratory disease. Also, one point is that coal is a limited natural resource and can get over. That is, it is exhaustible. What do you mean by exhaustible? That is, it can get over in the near future, right? Coal being a natural resource is limited, right? So all these are problems or the drawbacks of thermal power plant.